Okay, guys, welcome. This is section 1.1. So, this is the first recording, and it's about linear equation. Okay, so what I'm going to do first, the objectives are solve linear equations, solve equations that leads to linear equations, solve problems that can be modeled by linear equations. So we have three major objectives. Okay, and let's just talk about vocabulary first. Just quickly, something what requires probably the review. You guys also have PowerPoint on Canvas with vocabulary. Um, I think what you guys really need to know is identity, something what may be new. So let me put it. I'm not going to put all of the vocabs. Identity is equation. That is true. It's always true. That is true. No matter what value are chosen. Are chosen. So just quick example of identity. 15x plus 5 equal 5 times 3x plus 1. So this is identity because, first of all, when you simplify the right side, you end up with 15x plus 5. And on the left side, you also have 15x plus 5. So first of all, they are identical. But also, how are you going to know that you have identity? Let's say you're trying to solve for x. That means we want to move that 15x to the left side. So we subtract 15x from both sides. And that will give you just 5 equal 5. So the variable cancel and you end up with number equal number. So this is definitely true. So identity, it's equation which is true for any type of x. No matter what you plug in, for x, you always will end up with a true statement, which is 5 equal 5. Okay, and equivalent equation, let's just put it one extra. Equivalent equation, because I'm assuming everybody knows what is the equation, so I'm just putting something what may require review. Equivalent equations are equations which have exactly same solution. So sometimes students missing those two definitions, identity, equivalent equations. Equivalent equations, they don't have to look the same. Okay, so let me show you example. X minus 7 equal 3 and x minus 10 equals 0. So we have two equations. Those two equations are equivalent because they both have the same solution, which will be 10. So if you want to solve the first equation, you would just add 7 to both sides, and we end up with x equal 10. And to solve the second solution, you also will add 10 to both sides, and you end up with x equal 10. So equivalent equations, that's the equation we have the same solution. However, they don't have to look the same. So we have exactly right here, we have two different equations. However, they are equivalent because they have the same solution. So that was the review of vocab. Let's talk about how to solve the equations. Let me give you some steps of how to solve linear equations. Okay, let's just write this down. One method of solving equations is to replace the original equation with equivalent equation. So that's what we're going to do. We're going to interchange the two sides simplify the sides of equation by combining like terms, eliminating parentheses, and so on. So of course I will give you the hints, the equation which we solve. Next, what we're going to do, we're going to add or subtract the same expression on both sides. And then multiply or divide both sides of the equation by the same non-zero expression. And next, we're going to use zero product property. It's going to make sense what I'm writing here. Zero product property, which is A times B times, I like to put that, so we're not thinking that it's X. Equals 0 means A is equal 0 or B is equal 0. So this is zero product property. Okay, so I'm going to start solving equations. I have a couple equations which I definitely want to solve. So example 1, solving linear equations. Okay, we're going to start slowly with the basic one, which is one-step equation, 7x equal 21. So to solve the equation, you need to isolate x, since you have a multiplication in front of x. So what we need to do, we need to divide both sides by 7. Isolate x, that means you want to only have x on the left side, and we end up with x equal 3. Okay, so this is one step of the equation. Again, I know everybody can solve it. Let's do b. When we have variables on both sides, 3 plus 2n equal 4n plus 7. To solve those type of the equations, you want to, and this is what I'm always going to do, not confuse anybody, I want to keep variable on the left side and the numbers on the other side. So I need to move 4n to the left side. Since you have positive 4n, so what we need to do, we need to subtract 4n. So we always, when you're switching the expression to the other side of the equation, you always use the opposite, okay? And you always doing that to both sides. So 4n minus 4n will give you 0. So on the right side, we have 7. On the left side, we have 3. 2 minus 4n will give you negative 2n. And now we're solving. We want to isolate, we want to solve that equation for n. So what we need to do, we need to move that 3 to the other side, because that's where we keep the whole numbers. Since we see positive 3, you're going to subtract 3 from both sides of the equation. That will cancel, and you will end up with negative 2n. It's equals 7 minus 3, which is 4. In the last step, we're trying to solve the equation for n. We have negative 2 times n. So to undo the multiplication, we need to apply the division. So you're going to divide both sides by negative 2. And that will give you n equal negative 2. Okay. Okay, let's solve more. So we start solving equations which are a little more advanced. And for each type of the equation, I'm going to give you hints. Now, the next one, which I want to solve with you guys, are fractional equations. So let me first write the steps, okay? So let me review before we do more. So let's just review. I'll just give you a note, not review. For some of you may be new. So just write note. Okay, next one, I'm going to give you steps of solving fractional equation. Okay. So when you have equation which have fractions, first what you're going to do, you're going to look at the denominators of all fractions and find lowest common multiple which we call LCM. Sometimes they call it LCD. LCD, which is lowest common denominator. So again, they both mean the same thing. Next, lowest common multiple is the number which can divide each number which you see in the fraction. Next, you're going to multiply both sides of the equation by LCM When you multiply both sides by LCM, you're going to then distribute the LCM, which is going to be number most of the time, over both sides of the equation. Okay, next. If you did this correctly, your equation no longer have fractions. And you can continue solving by using basic procedures for solving equations. Okay, which means combine like terms. Only keep expressions with variables on the left side, move everything to the other side, and the last step will be divide both sides by the coefficient which you have in front of the variable. And check the solution. Usually I leave that for students to do it at home. Okay, so let's do the example 3, which have fractions. Okay, so let's go back. So we have 2 over 3p equal 1/2 p plus 1 over 3. So I'm going back to those steps, and first what I need to do, I need to find the LCM, lowest common multiple, of the numbers which I have in fractions. So we have fractions, and the denominators are 3, 2, and 3. So first what you want to do, you need to find lowest common multiple of 3 and 2. Since 3 repeats here, so we don't go into list twice. Lowest common multiple means a number which can divide 3 and 3, 3 and 2. So the lowest number which can divide 3 and 2 will be 6. 6 can divide 3 and 6 can divide 2. So when you find that LCM, next what you're going to do, you're going to multiply both sides of the equation by LCM, by 6 in our case. So I have that 6 times, and in parentheses I'm going to copy my original left side of the equation. Okay, so I have 6 times 2 over 3p equal 6 times, and in parentheses I'm going to copy the original right side of the equation, which is 1/2 p plus 1 over 3. Next, what you're going to do, you're going to apply distribution property. So you're going to distribute distribution property. So you multiply 6 by 2 over 3. Number multiplied by fraction, you only multiply numerator equal and distribute here. So 6 times 1/2, so you only multiply numerator of the fraction by 6 plus 6 times 1 over 3, and you copy the denominators. Of course, reduce. So 6 divided by 3 will give you 2, so you have 2 times 2, which is 4p equal 6 divided by 2, it's 3, so you have 3 times 1, which is 3p, plus 6 divided by 3, you're getting 2, 2 times 1, it's 2. And now we're just going to solve it. So like you see, we don't have fractions anymore, so the next step will be move variables to the left side. Okay, so since we have 3p on the right side, when you move the variables, you always keep the opposite. So opposite of 3p, it's negative 3p, so I'm subtracting 3p from both sides. And that will give you p equal 2. And that's our solution. Okay, so that's how you're solving the equations with fractions. Let's solve a little more advanced. So I'm going to solve example 4. We have x over x minus 2 plus 3 equal 2 over x minus 2. So this is also fractional equations. So I'm going to follow the rules how to solve fractional equations. So first I need to look what I have in denominators and I have to find lowest common multiple. Okay, so my denominator has x minus 2 and x minus 2. Since they both are the same expression, so lowest common multiple of x minus 2 is x minus 2 by itself. So don't forget that your fractions and denominators can be expressions. Okay, so lowest common multiple is x minus 2. So I'm going to multiply both sides by x minus 2. And why we do that? Because we don't want to have fractions. So we have x minus 2 times, and in parentheses, I copy the original left side of the equation, which is x over x minus 2 plus 3 equal LCM, which is x minus 2 times, and I copy the right side of the equation, which is 2 over x minus 2. Okay, so what we're going to do next, I follow the same steps. Next, you're going to distribute. Okay, so I multiply x minus 2 by fraction. So when you multiply the expression by fraction, you only multiply numerator. So you have x minus 2 times x, and copy the denominator, which is x minus 2, plus x minus 2 times 3. So I distribute x minus 2. And now we'll do the same thing on the right side. You have to multiply this fraction by x minus 2. So you only multiply numerator. So this is x minus 2 times 2 over x minus 2. Okay. Now the idea is to multiply both sides of the equation by LCM, that a lot of stuff will reduce. So look what happened. We have the same expression on the top and on the bottom, so that will cancel. And we only end up with x plus. Here you have to apply the distribution property. X minus 2 times 3 is the same as 3 times x minus 2. Okay, so I multiply 3 by x and 3 by negative 2. So we end up with 3x minus 6 equal, and again, don't distribute here because look what happened, you definitely can cancel that. So we only end up with 2. How are you going to know that you solve it, you simplify correctly? We don't have fractions anymore, so I'm 100% sure that we solve it. We're on a good track to solve this equation. Next, we're going to combine like terms. So x plus 3x will give us 4x minus 6 equal 2. And now numbers, we're moving to the right side. Since it's -6, we are going to add opposite, which is +6 to both sides. That will cancel, and we end up with 4x equal 8. And the last step, just divide each by 4. We're getting x equal 2. Okay, so this is the solution. Okay, one more equation with fractions, because I think that's the one which students struggle. So let me give you more examples, a little more advanced. Here we have 4 over x minus 2 equal -3 over x plus 5 plus 7 over x plus 5 x minus 2. So couple things, because I didn't do that before. And here we have to go back. Okay, so let me just go back here to the previous example. So what happened when you're solving equations with fractions and when our fractions has expression? So we'll talk about that soon, especially when we'll be talking about functions, but you always need to give condition, and I skip it here. So let me go back. We all know that you can never ever divide by 0. So here I need to give the condition that x minus 2 can't be equal 0. Okay? So what that means, you solve that for x, which means you will add 2 to both sides. And that means that it's very important that we know that x can't be equal to. Okay? So you read that x can't be equal to. Okay, so when you solve this equation, okay, you always have to check the condition. Okay, from condition, let me go. From the condition, because again, the only way that this equation is true is, and we can solve this equation when the denominator is not equal to 0. So from the condition, we know that x cannot be equal to, which means, again, x can't be equal to. So look what happened. We solve it and I end up with x equal to. Okay, so this is fake solution, extraneous solution. Fake solutions, we call it extraneous solution. Using algebra, we were able to solve this equation. However, that doesn't make sense, okay? We don't have a solution of this equation. X, we know that x cannot be equal to, because if you will try to check your work, and you will replace x with 2, so you end up with 2 divided by 0, which again, we cannot solving something like that. So here we end up with extraneous solution, which is fake solution. And when you have fake solution, your entire equation this equation has no solution. So if you will enter in my MATLAB x equal 2 as a solution, my MATLAB will mark that wrong, because when you have fractions, you always have to give the condition that the denominator cannot be equal to 0. Okay, so now, so the previous equation did not have a solution. Okay, very important. Okay, so now what I'm going to do, I'm going to start, since again I have fractional equations and I have dominators as expression, I'm going to start with the condition. Technically later that will mean the domain, okay? So I have to give the condition here. So condition, this equation will be true only if x minus 2 is never equal to 0. This equation is true only when x plus 5 is never equal to 0. And the last one, x plus 5 times x minus 2, like you see, they already repeating, so I don't need to put it because I already have them. Solve them for x, like you're solving equation. Just add 2 to both sides here. And you end up with x can't be equal to. In this one, to solve it, we'll subtract 5 from both sides, and we know that x cannot be equal 5. Okay, so this is important because when you will be solving this equation, and if you end up with 2 or negative 5, this is wrong. That equation does not have solution. Okay, so the condition which we also call domain, okay, so I will put it that the domain is all real numbers except x equal 2 and x equal negative 5. So this is important. The domain means that, again, you can solve this equation is true for any real number. Again, we'll end up with one solution except 2 and negative 5. That means if you end up with 2 and negative 5, it's going to be the case which we had before. We won't have a solution. So be careful with that. Okay. So let's go back to this problem. And since you have fractions, first you need to find least common multiple of the expression which you see in denominator, which is x minus 2 and x plus 5. And x plus 5. I'm not done yet. Okay, so the lowest common multiple of x minus 2 and x plus 5, I know they are two different expressions. What you're doing, you're going to multiply them. It will be x minus 2 times x plus 5. So this is our lowest common multiple. I don't want to give you a headache, but again, think about this. Okay, that will be note on a side. If I will ask you to find lowest common multiple of 2 and 3, you guys know it's 6. Okay, how we end up with that 6? You multiply those two numbers together. So 2 times 3 is equals 6. So that's how you know that your lowest common multiple is 6, right? So we're doing the same thing here. Again, we have expression x minus 2 and x plus 5. So lowest common multiple, just multiply those two expressions together. It's x minus 2 times x plus 5. So next what I'm going to do, I'm going to multiply both sides of the equation by, excuse me, LCM, which is x minus 2 times x plus 5. Note, don't distribute that. Keep it as a product because you want to cancel stuff. So, x minus 2 times x plus 5, which is again LCM, times the original left side of the equation, which is 4 over x minus 2, equal LCM, which is x minus 2 times x plus 5 times, and in parentheses, I'm going to copy the right side of original equation. Copy. organized. Okay. Okay. So now let's simplify. We're going to distribute. So just be patient with that. Okay, so distribute. Since we have a product everywhere, so this is the same as x minus 2 times x plus 5 times 4 over x minus 2. Okay, so that's how you distribute. You only multiply numerator. And before I move on, hope you guys see that x minus 2 and x minus 2 will cancel. Equal. And I'm going to do exactly the same thing on the right side. You treat that product as a one expression. So you're going to multiply that by this fraction. So that will give you x minus 2 times x plus 5 times negative 3 over the denominator, which is x plus 5. Hope you guys also see here that x plus 5, since there's a product between all of them, so you can cancel, they're repeating, so you're just crossing this out. Plus x minus 2 times x plus 5, you're going to multiply by 7. So we have x minus 2 times x plus 5 times 7 over, and copy the denominator, which is x plus 5, x minus 2. I know it looked bad, but look what happened. X minus 2, x minus 2 cancel, x plus 5, x plus 5 cancel. So a lot of stuff will simplify. So since x minus 2 and x minus 2 cancel, we only end up with x plus 5 times 4 equal. Here, x plus 5 cancels, so we only end up with x minus 2 times negative 3 plus x minus 2 and x plus 5 cancel, so we end up only plus 7. And now this is what we going to solve. So first I'm going to distribute. 4 times x will give you 4x. 4 times 5 will give you 20. Equal. Here you're going to distribute, so you have negative 3 times x, which is negative 3x. Negative 3 times negative 2 will give you positive 6. And of course you have plus 7. So simplify. 4x plus 20, it's equal negative 3x plus 13. Next, we're moving the variables. So move x's to the left side. So I have negative 3x, I'm going to move that to the left side. Since it's negative 3x, I'm going to add 3x to both sides of the equation. So we end up with 4x plus 3x, which is 7x. You still have that plus 20, equal, here everything cancel, 13. Now, positive 20 has to be moved to the right side. We're moving the numbers to the right side. Since it's positive 20, so opposite of 20, it's negative 20. We're subtracting 20 from both sides of the equation. That cancel. And this is just 7x equal negative 7. And the last step will be divide each by 7. And we have x equal negative 1. So this is our solution. So here we end up with a solution. I'm checking the condition. I know it was the long problem, but the condition is that we can have as a solution any real number except 2 and negative 5. So x equal negative 1, it's not 2, it's not negative 5, so we have the solution. So we end up with a solution. Okay. Okay, so that was equations with fractions. And next what I want to do, I want to solve the word problems with you guys. Okay, so next one, we're going to focus on solving word problems. So I'm going to give you the steps for solving apply problems. Applies problems, they are the word problems. Um, okay, so you guys have those steps on PowerPoint, so I'm just going to read them to you. They are, instead of writing them twice, read PowerPoint slide 9. So the first step, you have to read the problem and pay attention to the question being asked to identify what you are looking for. Step 2, you have to identify any formulas you may need. So when we talk about distance, you need, let's say, distance formula. Or if we're talking about speed, of course, distance formula. Okay. Next, you're going to assign the variable, which will represent what we are looking for. Then we're going to make the list of all known facts and we'll translate them into expression. We're going to solve the equation for unknown variable and we'll check the answer just to check if our solution makes sense. So of course, when you're solving problems with money, if you end up with negative, something is wrong. So I'm going to solve problem from your textbook. I know you have e-version of a textbook, but this is from page 91, number 83. So let's solve this one. So we have a total of 20,000 is to be invested. I'll just write this down because it will take me longer to log into that textbook. Sum in bonds. And sum in certificates of deposit. If the amount invested in bonds is to exceed those NCDs, certificates of deposit, by 3,000, how much will be invested in each type of the investment? Okay. So here we're going to read it. First of all, they talking about two different type of investment. They talking about bonds and CDs, which we call certificates of deposit. Okay, we have 20,000, which we want to invest. What we also know, we know the amount invested in bonds is to exceed the one in CD by 3,000. So the idea is to solve this problem only with one equation, which means one variable. So what's going to be your variable? Then the idea is when you guys solving the word problems that when you're comparing two amounts or two different variables. Uh, in this case, we compare bonds to CDs. So the one which we are compared to, that's your variable. So we know that bonds are being, the money invested in bonds exceed the one exceeded by 3,000. So your variable, I will call X, is money invested in CDs because we comparing bonds to CDs. Okay, so now you have to figure out how you're going to express money which we invest in bonds. So this is your sentence. We know the amount invested in bonds is to exceed in CDs by 3,000. So in bonds, we invest 3,000 more than in CDs. So that will be 3,000 plus X, because we don't know yet how much we invest in CDs, but we know that in bonds we'll invest 3,000 more. So now we need to figure out how much money we invest in CDs, how much money we invest in the bonds. You need to create the equation. How you're going to create that equation? Your first sentence tells you, give you very important information. You have a total of 20,000 which you want to invest in two different savings accounts. So we have 20,000 and you want to invest them in bonds and CDs. So bonds, it's 3,000 plus X plus money which invests in CDs, we call that X. And together we'll end up with 20,000. And now we're just going to solve this equation. So we have X plus X, that will give you 2X plus 3,000 equal 20,000. Subtract 3,000 from both sides. And we end up with 2x equals 17,000 and divide each by 2. And we end up with x equal 8,500. So now when we find x, we're going back, we call x money invested in CD, okay? So we invested 8,500 in CDs. So now we need to figure out how much we invested in bonds. So money invested in bonds is 3,000 more than in CDs. So 3,000 plus X, it's equal 3,000 plus, since we know X is 8,500, so we have 11,500. 11,500. Okay, so this is money invested in bonds. And of course, you want to check if that makes sense. We know that together we had 20,000, so 11,500 plus 8,500 will give us that 20,000. Okay, so let's do another example. So more word problems. Next one, I'm going to solve number 85. I believe it's also from page 91 in your textbook. So this one, it's about Sandra. We have Sandra, who is paid time and a half. Time and a half for hours work in excess of 40 hours. So she's getting overtime 1.5 of her regular paycheck if she work more than 40 hours for every hour after 40. Had gross weekly wages of 546 for 40 hours worked. What is the regular hourly rate? Okay, so what they ask you here in this problem, how much Sandra makes per hour? Okay, so my variable will be x. Amount paid per hour. Of course, without overtime. So just her hourly rate. Okay, so what we know that she's going to pay time and a half, which is 1.5 for each hour, or just for each overpaid hour, which means hours after 40. So they pay her 1.5 of x. That's the amount paid for overtime. Okay, so now we have to create the equations. What we know that Sandra bring home 546. So her last paycheck was 546, and we know that she worked 48 hours. So we need to calculate how she made that 546. So she worked 48 hours. So we want to break this down, that 48 hours of work. We know that she has regular 40 hours of regular pay, and she has 8 hours of overtime. So here this is regular pay, 40 hours, and 8 hours is overtime. Okay, so what we know that for 40 hours, she's receiving her regular hourly rate, which we don't know yet, that's your x, plus she has 8 hours of overtime. So those 8 hours, her salary, her rate is 1.5, 1.5 of regular pay. So this is 1.5x. And together you get 546. So let's simplify that. We have 40x plus 8 times 1.5, which is 12, plus 12x equal 546. We end up with 52x equal 546. Divide both sides by 52. And we end up with x equal 10.5, which means amount paid per hour. Per hour is $10.50. So how much she's going to get paid for overtime? They don't ask for that. The amount paid for overtime is 1.5 times her regular hourly rate. So 1.5x is 1.5 times $10.50, which is 1.5 times $10.50, 15.75. So she makes 15.75. This is amount paid for each overtime hour for overtime, which means it's for each hour after 40 regular hours. Okay, and I will solve one more, and I think that will be enough. One more word problem for you guys. So next one, I want to talk about number 88 from page 91. Here we're talking about calculating what we should receive from the final exam. So going into the final exam, which will count as 2/3 just a lot of the final grade. Mike has test scores of 86, 80, 84, 90. So that's his grade so far. What minimum score does Mike need on the final in order to earn B? B requires average of 80, which means 80%. Okay, 80. Okay, so let's talk about it. So we're talking about trying to figure out what Mike should get from final exams. I'm going to call X final exam grade. Okay, 80%, which we can just put as 80. Okay, so this is what we know. So how we know how the teacher calculates the grade? We know that final exam, 2/3 of final grade. So when Mike wants to end up with 80. So he's getting something from final exam, which is X, maybe 75. And that final exam grade represents 2/3 of his grade. So you're going to multiply by 2/3. Okay. Okay. So of course we need to get whole. So that means the test which he had so far, he had 4 tests, 86, 80, 84, 90. So all those tests will represent 1/3 of his grade. And of course, what we need to do with those tests, you need to take average, because that's how you calculate your grade. You had 4 tests and you want to get the average from those 4 tests. So we're going to divide that by 4. So we need to figure out what is X. Hopefully that makes sense how I create that equation. His final exam multiplied by 2/3, that means the average of the 4 tests which he took represents the 1/3 of his final grade. So what we're going to do, we're going to simplify those fractions. Or maybe let's first calculate that average. Let's simplify this part. 86 plus 80. We have 86 plus 80 plus 84 plus 90, 340, and when we divide by 4, this is 85. So the average, it's 85. So that's the average from his test, which he took. So 85, that average represents 1/3 of his grade, plus 2/3 x equal 80. So like you see, your denominator is 3. So I'm going to multiply both sides by 3. Your LCM is 3. So I have 3 times, I copy the left side of the equation, which is 1/3 times 85 plus 2/3 x. It's equal 3 times the right side, which is 80. Okay, so now I'm going to distribute 3 times 1/3, that's just 1, so we end up with 85 plus 3 times 2/3. So again, 3 will cancel, you end up over there with 2x equal 240. So again, I'm showing work. 3 times 1 times 85 over 3. That's how I end up with that 85 right here. And then 3 times 2 over 3x. That's how I end up with 2x. Okay, which is right here. So now we're just going to subtract 85 from both sides. So we have 2x, it's equal to 240. 240 minus 85, this is 155. And divide each by 2. So 155, we're dividing that by 2, this is 77.5. So x is equal 77.5. So what that means, Mike has to get at least 77.5 to earn B from this class. Okay, so I'm going to stop here. Okay, this is section 1.2. The next video you're going to see section 1. This is not 1.2, this is section 1.1. The next video which you're going to see, it's going to be section 1.2. So thank you so much for watching.